Hello everyone and welcome to the next topic for statistics called regression. Now regression is all about plotting a trend line that represents the data. Let's look at all the data points plotted with some y and x value. Now this black line that I've drawn is kind of like a linear trend line that shows you the trend of these values. And we can see that y increases as x increases. We can see that this trend line, or what I like to call the line of best fit, actually really matches the data. And hence we can say that y and x have a very strong correlation. An example of two variables having strong correlation with each other could be that the x is the number of hours spent training, and the variable for y could be how tired you are. So the more hours you spend training, the more tired you are. There's a mathematical way of determining how strong this correlation is, and this is using Pearson's correlation coefficient. Now this correlation coefficient is what we call R. This value of R will be between -1 and 1. 1 represents a perfect positive correlation and -1 represents a perfect negative correlation. This over here is a positive correlation because it has a positive gradient. But let's say if your line of best fit looks something like this instead, then this has a negative correlation. So if you have an R of between -1 and -0.85, this is called a strong negative correlation. So it's still a strong correlation, but it's just that your gradient is negative. For an R value of let's say between 0.85 and 1, this is actually a strong positive correlation. Now a weak correlation will look something like this. This generally has quite a low R value, and the data points are all further away from the trend line. That's what we call a weak correlation. Now there are two different types of regression lines that is very important for you to remember. So first off, we have the regression line of y on x. This will have an axis something like this, similar to this and this. Now we'll use the regression line of y on x when x is given and used to predict y. So let's say in our earlier example, x will be our number of hours spent training and y will be how tired I am. Given the number of hours I spend training, which is your x value, I can predict the amount of tiredness you have, your y value, using the regression line of y on x. And this can be written as y equals to mx plus b. However, the regression line on x on y will instead look something like this, where x equals to ay plus c. This is when your y is given and used to predict x. So let's say I'm given your amount of tiredness, I can use that to predict your number of hours spent training based on the regression line of x on y. Now what I want you to note is that these two lines are completely different. Even if you use this to try to express x in terms of y, that is wrong. You will not get your regression line of x on y. Another property is that both your regression lines will pass through x bar, y bar. X bar is your mean of all your x values, and y bar is your mean of all the y values. So both of these lines intersect at this one specific point over here. Now the last bit of content I'm going to cover is extrapolation and interpolation. Let's say I have this black line over here like this, and I have black data points. Extrapolation is when you try to predict beyond your x and y values. So maybe let's say your highest x value over here is when x equals to 5, and you're trying to predict what y is when x equals to 7. This is what we call extrapolation when we're trying to take beyond a certain x and y value in your data set. This is actually inaccurate. However, interpolation is accurate. This is when you're taking values within the range of x and y values. So let's say you have x equals to -1 here, and let's say x equals to 5 here. If you're trying to predict what y is when x equals to 2, that is accurate, since we're trying to predict within the range of x or y values given. Now let's look at this question, which is a very common question in paper 2. I'm going to show you how to use the GDC to solve this. Find the correlation coefficient R and the regression line of y on x given this following data. In our spreadsheets again, we want to key in the data for x into the first column. We always want to key in the x values into the first column. So we have 20, 23, 30, 38, and 39. Then we want to key in the corresponding y values into the second column. So we have 26, 45, 48, and 46. Now let's highlight these two columns, so we click the up arrow until it reaches the top and selects the entire column in blue. Then press Shift, right click to select the second column as well. Now to calculate the correlation coefficient and the equation of the line of best fit, we go to Menu, Statistics, Stat Calculations, and this thing called Linear Regression. Now we press OK and we get all our values. First we come over here to the R value, so your Pearson's correlation coefficient is approximately 0.938. Now if we come up here, M will be the gradient of your line of best fit and B will be your vertical intercept. So your regression line of y on x will be y equals to 1.12x plus 5.53. Now the question didn't ask, but how do we find the regression line of x on y? What we can do is select everything again. So select column A and B, click Menu, Statistics, Stat Calculations, and Linear Regression. When we come here to this menu, we'll switch the x and the y list. So the x list will be column B and the y list will be column A. This basically tells the GDC that we want x to be on the vertical and y to be on the horizontal axis. Now you realize your R value is the same. Your Pearson's correlation coefficient is still 0.938. Now your new gradient will be M and your new vertical intercept will be B. So your regression line of x on y should be x equals to 0.788y minus 0.75. Here's a summary sheet for all the content for regression. Thank you so much for watching.